You understand how to solve problem number 2? You set up this matrix for problem 2, which would be a 1 and a 2, and what would it be? A -1 and a 5. Everybody see where I'm getting those numbers for problem 2 on page 617? And a 2 and a 1 and a 1 and a 1 and then a 1 and a -1.
Where are you getting all the ones from?
What?
Whenever there's just an X,
Oh.
there's a 1 before
It's 1x, so it's just, here's the way they say it in mathematics. It's understood that 1 goes in front of it, and you go, well, I don't understand it. But that's exactly what it is. A 1, a -1, and then what's the next one? A 1 and a -1. And then we'll just mess around with this thing by taking a row times some number, add it to another, till we get it down to where it looks like 1, 0, 0, something, and 0, 1, 1, something. No, 0, 1, 0, something, and then 0, 0, 1, something. Remember from reading all that stuff, how we would just mess with it till we got it down to look like this? And then the answer would be, this is the x column, so x would equal this, y would equal this, and z would equal this. You follow the process?
Kind of.
Not
Well, I see
really.
what the goal.
How do I get from this to make it look like this?
Yeah, that's what I
Yeah.
don't know.
It's like, that's what gets complicated.
Yeah.
And the thing is, you can take a row, like if I wanted to make this a 0, I would take this times 2, and that would make this -2. So this whole row times 2 added to this row would turn that into a 0.
That makes no sense at all.
You have to multiply the whole row?
You take the whole row times 2, and that means this would be 3, and this would be a new row, would be 3, 0, 1, and 3.
Why would it be that way though? I don't understand.
Because all I did was take one equation times some number, and if I add this and this, I can replace this row with the new one, and it doesn't change the total equation.
Wait, why did you pick 2?
Because I want this to become a 0 and 2 and -2.
Well,
Because I want this to go 1, 0, 0.
but like,
Just like I want this to be 0, so let's just add this row and this row, and what do you get? 1 and 1 is 2, 1, 0, and 4.
Why does that work? I don't get it.
It just works. What happens if I add this and this? That's 2. This and this is 1. This and this is 0, and this is 4. So now I replace 1, 2, -1, 5 with 2, 1, 0, 4.
how do you know you can put that there?
You just can't,
Well,
because,
if you put it there, can't you put it on the bottom too?
well, I could put it, that's right, I could put it anywhere. In other words, I could take this times something and add it to this one. I could add this one to this one and change this one to 0 here. But see, I'm going to want a 1 there eventually. So I'm wanting to get rid of, I want 2 zeros. And you just keep, and when you read the pages, you saw how they just kept monkeying around with them, taking them times something and adding to where they eventually got it down to look like this.
It didn't, yeah, I was not following.
I didn't get it though.
But you see why you can do that, because this plus this makes a new equation, but I can still put this new equation. This equation is equal to this, so I can put it in place of that one.
Why do you start with the bottom one?
You can start with any of them. See, you have all kinds of possibilities of how you can do it.
So do you add the horizontal way or the
No, you're always taking a row and adding it to another row.
So you just keep adding each
And you
one
just
to
keep
each
doing
other?
that till you end up with 1 0 0 something, 0 1 0 something, 0 0 1 something.
That seems like a lot.
And it is. It's a whole lot of steps, and there's more than one way to get there. So there
Can
must
you
be
do
some
several of them or something.
there must be some way to get some help with this.
I know, like in
So
college
let's
algebra when I did this, I definitely.
so let's go to
online.
what's our favorite place?
Easy count.
Easy calculation.com. All right, let's go there. And
Could you
Let's-
turn on the projector so we can see it?
oh, good idea. easycalculation.com. And once that pops up here, I go down and look at all of these, and they have more stuff than you can imagine. So I'm just going to go back up here and type something in. Matrix, algebra, calculator. You want to write that down? Oh, there it is. Matrix, algebra, calculator. Because I searched for it once before you got here, so it'd be on the computer. Everybody have that written down?
What was it?
Matrix. So when you get to easycalculation.com, you go to the little search box and you type in matrix, algebra, calculator. Now watch what happens when I click on this. A whole bunch of stuff shows up here, but since I'm using easycalculator.com, we'll go down to the easycalculator.com one and click on it, and watch what happens. Voila. Now, let's do problem number 2. Let me erase this stuff that I put up here. And we're going to mess with this and end up with something that looks like that. So, what's the first number? 1. Is that right?
Yep.
What's the second number?
2.
2. What's the third number?
1. Well, -1.
Okay, so I change this from positive to negative and put 1 in there. And what's the last number?
5.
5. Then I go to the next one and I put in 2. And then what do I put in?
1.
1. And then what do I put in?
1.
1. And what do I put in next?
1.
1. Go to the third row and what do I put in? What's in front of X?
1.
1. And for Y?
-1.
Will it let me go -1? Well, it sure did. And Z is 1.
Mm-hmm.
And this is -1. Can I do it again? Says it did it. Then let's say calculate. And look what happens. X is, uh-oh, I bet I did something, maybe I did something wrong. Let me click this and make this -1. Maybe I can't do that even though it let me do it. -1. Just one. And where did I put another one in? Over there. Now let's do calculate and see what happens. Oh, down at the bottom. There it is. See that? Results? 2, 0, negative 3. Let's go back up here and change this back to positive and see if we get the same answer by me putting a negative 1 in here. Calculate. Did we get the same answer? 2, 0. Was that what it had before? 2, 0, negative 3?
I don't know.
You're not going to tell me. Okay, so then I'll go back and make this negative and try to remember this time. And then say calculate. What's it say? 2, 0, negative 3. So, what happens is now in this thing over here, 2, 0, negative 3. So x is 2, y is 0, and z is negative 3. So the calculator just did all the work for you.
Are you gonna let us use that on the test?
Yes. I mean, why not? If it's there, why go to all that work manually if it's already there?
Do we not need to know how to do it?
Which is the one that you got? Did you get that?
It doesn't do this though. I do
You know
get
what
that.
I would say?
It was called
I can't think of any place in the world where you would have to know how to do this.
without having a calculator.
Because there's so much available on the internet. Did you see how many places you can go to find places to help you do this matrix algebra calculation? So you just have to know where to plug the numbers in and then where to look down for the results. Okay, so let's hit reset and let's do another one. Two, 4, 6, 8, 10. You want to pick one? Oh, we've done 2, 4, 6, 8, or 10. Which one you want to work?
How about 4?
Okay. So, what goes here? Look at number 4.
Oh, it's number 4. 1,
1. What goes here?
2,
2. What goes here?
1. Negative 1.
I'm going to go ahead and do, just since they've got that there, I'm just going to go ahead and see where it says negative. Whoops, I didn't move it. Move it down to negative 1. And then what's last? What goes there?
0.
0. Next row. What goes here?
2.
And what goes here?
3.
And what goes here?
There's a blank space.
So, what would that mean if there was a blank space?
0.
Yep, that's right. 0. And what goes here?
3.
3. Then let's go down to the next one. What goes here?
There's another blank space.
So, what do you put?
0.
0. What goes here?
2.
2. What goes here?
1.
1. And what goes over here?
Negative 1.
Negative 1. And hit, looks like it already did it. 3, negative 1, and 1. X is 3, Y is negative 1. You see that down there?
Mm-hmm.
X is 3, Y is negative 1, and Z is 1. So what do you think?
Why would we want to make the thing of numbers, the matrix of numbers?
The
Why would
matrix?
we want to make it with ones and zeros?
Oh, why do you want to get it here?
Yes.
Okay, here's what you're trying to find out. For number 4, the one we just did, what 3 numbers can I put in place of x? Let me just erase this stuff that I have up here. And let me put problem number 4 up here. Okay, what number can I put in place of x, y, and z that makes a true statement? 3, -1, and 1. 3, -1, and 1. 3, -1, and 1. 3, -1. Whoops. Erase that. I could put 3 out here, -1, and 1. Okay, what's 2 times -1? -2. What's -1? What's 3 minus 2 minus 1? 0. What's 2 times 3? 6. What's 3 times -1?
-3.
What's 6 minus 3? Oh. 2x plus 3y equals, I copied it down wrong, didn't I? What goes here?
3.
3. So 6 minus 3 is 3.
Mm-hmm.
And this was 0, right? So I get 3 for an answer. There's nothing here, so this 3 is gone. What's 2 times -1? -2. Plus 1, what does that equal?
-1.
-1. So what you just did, and this is why if you do it manually it takes so much work, you just found the 3 numbers. 3, -1, and 1. You just found the 3 numbers that will satisfy all 3 conditions. So you just found the solution set to this system of equations. That's why it's so complicated. And that's why there's a place on the internet to do it. Okay? So now, so you know what to do for problems 1, 3, 5, 7, and 9, right?
Mm-hmm.
So let's skip 11 and let's go to 12. And what does 12 say? Tell me what 12 says.
The sum of $8.50 is made up of nickels, dimes, and quarters.
Nickels, dimes, and quarters. And it adds up to 850 cents.
$8.50.
But how much is a nickel worth?
10 cents.
A nickel?
So, no, 5 cents.
A nickel's worth 5 cents. How much is a dime worth?
10 cents.
10 cents. And how much is a quarter worth?
25.
So if I take 5 times each nickel, plus 10 times each dime, plus 25 times each quarter, I'll get 850 cents.
Yep. I get mixed up how minutes and dollars are counted.
Everybody see what I did here?
Oh, yes.
Okay, you want me to close this blind?
Yes.
Which one is it? That one?
That one, yes.
Yeah.
Thank you.
That's hurting my eyes because it's hurting your eyes. Okay, what's it say next?
The number of dimes is equal to the number of quarters plus twice the number of nickels.
The number of dimes equals what?
The number of quarters plus twice the number of nickels.
Plus 2 times the nickels.
The value of the dimes exceeds.
Okay, does everybody see where we got that?
Value of the nickels.
Does everybody see where I got this sentence here? She's reading the words, and I'm putting the math symbols up here. The number of dimes equals the number of quarters plus twice the number of nickels.
Yep.
Now, what's the next thing it says?
The value of the dimes exceeds the combined value of the nickels and the quarters by $1.50. How
So-
many of each coin are there?
The value of the dimes would be 10 times D, right? And does that equal the value of the quarters and the nickels?
No,
It exceeds it by how much?
$1.50.
So if I want this to be equal, I'm going to have to subtract 150 cents. You follow that? Because this number is 150 cents larger than, what did it say about the quarters and the nickels?
The value of the dimes exceeds the combined value of the nickels and quarters by $1.50.
5 times n plus 25 times q. Everybody see that? The value of the nickels, 5 times n, plus the value of the quarters, 25 times the number of quarters, and the dimes, the 10 times the number of dimes, is large. In other words, those two numbers aren't equal, are they? This number is larger than that one, so I have to subtract 150 from here to make it equal.
Okay.
Now I'm ready to turn it into the form that I can use on the computer. So I go 5n from up here plus 10d plus 25q equals 850. Okay, that's good enough. Okay, what do I do here? I want nickels, dimes, and quarters. So I go, let's see, how about if I did this? Make it equal to 0, then that would be 2n minus d plus q equals 0. Is that okay if I did that? So now I can write down here 2n minus d plus q equals 0. Everybody follow what I did to get that? I basically just subtracted d from both sides and then rearranged them. So now we're ready for the third one. So I have 5n, then what?
Negative 10d.
Minus 10d plus 25q. So let's just put it up here. 5n minus 10d plus 25q equals
Negative 150.
negative 150. Everybody follow that? So what happens is, with the story problems, you have to go from the words to math, then you take the math and set it up in this little format that you need to put it on the computer. So now let's solve this problem. Let's turn this thing on. That's it. What's going on? What did I do? There. I don't know what I did. Let's come over here. And let's reset. And let's go up here and fill in our numbers. What's the first number?
5.
We're down here at the bottom.
That's 5.
Right here, this is where we're going to get our matrix. So we put a 5 in there. What's our next number?
10.
What's our next number?
25.
And what's our last number?
I can't see it. It's 850.
850. Let's go to the next one. What's our first number?
2.
What's our next number?
1. A -1.
Click on -1. What's our last number?
1.
1. And what's the Z?
0.
0. Let's go to the third row. What's the first number?
5.
What's the next number?
-10.
-10. What's the next number?
25.
25. And what's the last number?
-150.
-150. And it says calculate, but it's already done it. So what do I have here? See the results? I have what?
20, 50, and 10.
I have 20 nickels, 50 dimes, and 10 quarters. Is that cool?
It's pretty cool.
Yeah, I like that a lot better than doing it by hand.
But that's right, because just like when we started talking about, that's why I wanted you to read those pages, because when you read them, you go, why are they doing that? Why not another row? And it's just like, and there's so many different ways you can get there that it just drives people nuts. And because it's so readily available today to you on the internet, why do you have to do it by hand? You know, when I went to college, a calculator that would compute square roots cost over $100. So they taught us in class how to find square roots manually.
Takes so long.
That's the horse and buggy days. And it's just like, why mess with it? I mean, for me, it's fun messing with a matrix to try to get it down to that identity matrix thing. But hey, it's not worth it to you to have to mess with that because it's readily available on the internet. Okay, so
That's the end.
what else do we have here? Number 13. Oh, that's one of yours, isn't it? So now, here's what you have to have. Here's what you have to say. For number 13, you have to figure out how to set this thing up. So, how would you set this thing up?
You use the table and then they would equal.
Okay, let's do number 14 and see if you can figure it out. Okay, we got a table here with what? Candy, peanuts, and sandwiches. Candy, peanuts, and sandwiches.
The issue is you're gonna have to use the answers from problem 13. It says.
And we have 20, 24, and 30.
Is this number
20,
15?
24,
14.
and 30. Is that right?
Mhm.
And 10 and 18 and 10. I mean, 20, 24, and 30. And 10 and 18 and 10. And then what? 0, 30, and 30. And it's 1, 2, the kind of machines, right? Let's call this X, Y, and Z. Doesn't that help to do that? Or A, B, and C, but let's call it X, Y, and Z. Now, what does it tell you in problem 13? The total daily sales for candy was what? 760? So, candy, whoops, put it in the wrong place. Candy from all three machines was 760. So what's next? Peanuts was what?
380.
380. And sandwiches was
660.
660. Now do you see how you're going to set it up? 20x plus 24y plus 30z equals 760. 10x plus 18y plus 10z equals 380. And 0 times x plus 30y plus 30z equals 660. Now, once you've got that set up, now you go to the calculator, don't you? Plug in the numbers, and you find out the answers. Okay, now let's do number 14. Suppose the total daily income from the various types of machines. So from this machine, the income is how much for number 14?
Type 1 is $32.
Type 2 is $159. And type 3 is $192.
So this is 32, and this is what?
159.
159, and this is
192.
192. Now, do you see what's going to happen? To set this up, let's call this A, B, and C. Or, no, let's just do it like that. I'm going to have 20C plus 10P plus 0 equals 32. Everybody follow what's happening now? I'm making my matrix going down. For the second machine, 24C plus 18P plus 30S equals 159. And the third kind of machine would be 30C plus 10P plus 30S equals 192. And how would I put that in the machine? I would just call that X, Y, and Z. You follow me?
Let me see. Yeah, but why would you do it up and down? Why can't you do it across?
Because they said for this machine, this is the total income.
Oh.
Whereas here, they said for candy, this is the total sales. So you put those totals down at the bottom of where they all add up, and then you say, okay, so now my equation is going to go 20C plus 10P plus 0S equals 32.
Okay. So
So there's no reason to do any more than that, because now you're just going to plug it into the calculator and it'll give you the answer. So I'm going to leave 15. We've done enough of this where you should be able to do 15 by yourself, and that's where we stop.
Oh.
15. So
Wow.
you only have one problem that you have to work by yourself.
Okay. That sounds good.
Okay, so now we're ready for page 631, topic 9.3. See, that's the beauty of the calculator. It does so much for you. And since I didn't tell you to read anything, I have a handout for you.
How kind.
How fun.
Thank you.
As my grandson would say, how pleasant.
Bugs. I don't know why I thought that I needed to tell you that. It's bugs.
That's pretty cool. Look, 9.3.
All right. Oh, I already have one here. So, in problems 1 through 8, find the sum in clock arithmetic. And when they say clock arithmetic, here's the clock. 12, 6, 3, 9,
Did you just go 9?
1, 2, 4, 5, 7, 8, 10, 11. That's clock arithmetic. What does it say to do here?
I'm so confused.
It says 2 plus 8.
So 8.
So that means I go to 2, okay? And then I go 1, 2, 3, whoops. I go 1, 2, 3, 4, 5, 6, 7, 8. And where do I end up?
So you start with this number and then you go over here. So like for the first one, you go 9.
See what I just did? I went to 2 and then went 8 more jumps and ended up at 10. Now do you see why I gave you this chart?
Yeah.
So what's the purpose of this? Okay,
So
we'll come to
go
it.
down to 2 and across the top to 8, and what's the answer?
10.
That's pretty handy.
So you can draw the picture and just do jumps around the circle. You can look at the chart. Whatever works best for you.
I feel like the chart's going to do.
Let's do another one.
Yeah, that's what I'm thinking.
Let's do number 6, 9 plus 9. And they put plus in a circle because it's clock arithmetic. 9 plus 9. Now, if I did what I just did here, I would go all the way around to 9 and then go what? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I would end up at what number?
6.
6. But watch this. In your head, what's 9 plus 9?
18.
18. But clock arithmetic only goes to 12 and starts over. So subtract 12 from that, and what do you get? The answer. Is that a cool technique too? In other words, there's 3 ways to get the answers to these problems. You can have a picture and walk around the picture. You can use the chart. Or you can say, hey, 9 plus 9 in my head is 18. And so I go 18 minus 12, and that leaves me with 6, because 12 just goes to 12 and starts over, 12 and starts over, and 12 and starts over.
Okay.
So which do you like best? Going around the circle? Using the chart?
I think the
using
chart.
You like using the chart?
Well,
Okay.
but in subtracting.
So let's go to problems 9 through 14. And what's 9 through 14 say? Find all the ends that satisfy each equation in clock arithmetic.
Wait, it's
So number 16 says,
wait, how do you do, like, for example, problem 9? How do you do the subtraction?
oh, I'm sorry, I skipped 9 through 14. Let's do 10. 5 minus 8. Thank you for bringing that up. 5 minus 8. Okay, I would go around to 5 and then do what? If it's minus 8, I would go 1, 2, 3, 4, 5, 6, 7, 8. Where'd I end up?
9.
9. Oh,
9. But look at that little chart I gave you.
You go to 8.
5 minus 8 means the same as 5 equals 8 plus 9. Everybody see
That'd
that?
just be 9.
Mm-hmm.
Or maybe it'd be easier to see 9 plus 8
Mm-hmm.
because you add 8 to both sides. So 5 minus 8, if 5 minus 8 equals n, then 5 equals n plus 8.
Okay.
So I could just do subtraction with my circle, or I could say I go to 8, and what do I add to 8 to get around to 5? 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is 9.
Okay. So you can't use the chart for this?
Oh yeah. For those of you who like the chart.
Yeah.
So 8 plus what number would equal 5? Go down the column to 8
Mm-hmm.
Oh, and then
and
you just
go
look for
over
the
to the
flag.
answer till
So
you
it's
find
9.
5.
Touchdown.
And what number's at the top of the chart?
9.
Do you like having 3 ways to find the answers to these problems?
This is fun.
This is what? Fun. Did I hear someone say that? Okay, so now you see how to do subtraction. Now let's do 15 through 22. Oh, now that I've showed you that little trick, 15 through 22, for 16, n plus 8 is 2. So if it says n plus 8 is 2, then that means n. No, what does that mean? It means what number do I add to 8? Let's erase all this. I go around to 8, and then I add something to get to 2. 1, 2, 3, 4, 6. So n is 6. Look at your chart. 8 plus what equals 2? Go down to 8, across to 2, the answer, and what number's up above?
6.
What?
6?
Wasn't it?
Yeah.
Go down to 8, across the answers till you get the answer of 2, and that number was 6. So 6 plus 8 is 2. Now watch this. In your head, what's 6 plus 8? 14. But clock arithmetic doesn't go to 14. It always stops where?
At 12.
So minus.
12 is 2.
So you see what happens? Oh no, you can't do that way because you don't know what that is yet. Okay, so you're looking for n. So either use the clock or use the chart. All right. So can you work all of those, 15 through 21?
Yeah, I think so. Does it matter if the numbers are switched around in their order?
Which one?
17.
2
S-
plus n is 1.
Yeah. Like, would you
Would
just...
2 plus n be the same as n plus 2?
Yeah?
Yeah.
So you could switch them around if you want to.
So that would just be looking at the chart, going down to 2. And
But
then
you go down to 2
across.
and across to
So you
1.
find 1.
And what number was that?
11.
11.
Okay.
And you know what to do with subtraction, don't you? I mean, I could just 3 minus 5. Am I looking at yours or mine? Ooh, let's look at mine. 22. 3 minus 7 is n. Okay, so I go to 3. Then I go back what? 1, 2, 3, 4, 5, 6, 7. And the answer is 8. But 3 minus 7 is n, so 3 equals n plus 7. So what do you add to 7 to get 3? To get an answer of 3?
Which problem number are you on?
22.
Oh.
8.
8. Yeah. 8 plus 7. Because what's 8 plus 7? 15. I don't have 15. It's 12, 1, 2, 3. So I can always check it out by just doing the math in my head. Find the indicated products in clock arithmetic. 23 to 28. 24 says 3 times 8, right? Okay, that just means, all that means is go around this thing. Here's 8. And then here's another 8. And then here's my last 8. And where'd I end up? 12. Everybody follow that?
No. Do it again.
Okay. I went around to 8.
Okay.
That's once. 1, 2, 3, 4, 5, 6, 7, 8.
That's 12.
Another 8. I'm at 4.
Okay.
1, 2, 3, 4, 5, 6, 7, 8. Another 8. 8 3 times. I'm at 12. But in your head, what's 3 times 8? 24. Subtract 12 from 24, and what do you get? 12. Now, isn't 3 times 8, isn't that the same as, on your little handout, doesn't it say that's the same as 8 plus 8 plus 8?
Yeah.
Multiplication is just repeated addition. Okay, look at your addition chart. What's 8 plus 8?
That would be 4.
4. What's 4 plus 8?
12.
There.
Oh.
So you can take your multiplication problems and draw a circle, or you can take your multiplication problems and make them a series of addition problems and use your chart. Well, number 29 says make a table of multiplication facts in clock arithmetic. That just seemed like a lot of work. So I just made one for you. This is just too much
Oh,
fun.
thank you so much.
Thank you.
That is really helpful.
I just copied the answer book and said, there's no reason for them to have to go to all that trouble. Just give them one. So now you have another way to do 3 times 8, don't you? Go down 3, across the top 8, and it'll tell you what the answer is. All right, in problems 35 to 40, find all n satisfying the given equation in clock arithmetic. And what does 36 say? N divided by 2 equals 4. Okay, what does your little handout say about division problems? That's the same as saying n equals 4 times 2. Agreed? So what's 4 times 2?
8.
8. There you go. So number 37. Let's do one of yours. N over 2 plus 4 equals 8. N over 2 plus 4 equals 8. So that means N over 2 equals 8 plus 4. Agreed? What's 8 plus 4?
12.
12. So N over 2 equals 12.
Wait, when you move the 4 over, wouldn't it be 8 minus 4?
Oh, you're right. Thank you. Minus 4. So 8 minus 4 is what?
4.
So N over 2 equals 4. So N would equal 4 times 2. What's 4 times 2?
8.
8. Check it out. What's 8 divided by 2? 4. What's 4 plus 4? 8. Okay. Now we quit doing clock arithmetic, so we erase this, and we start doing modulo arithmetic.
Oh, we have a table for this.
42. 5 equals 2 in modulo what?
What's modulo mean?
3. Here's what modulo 3 looks like. 0, 1, 2. Modulo 3 means it has 1, 2, 3 parts around the circle. And it doesn't start like a clock with 12. It starts with 0, 1, and 2.
Oh my.
But why in the addition modulo 5 it goes to 4?
Here's modulo 5. 0, 1, 2, 3. Whoops. Didn't get a part of a part, did I?
Wait, so why does modulo?
Because
5.
modulo 5, if modulo 3 has 0, 1, 2, what's modulo 5 going to have? 0, 1, 2, 3, 3, and 4. Okay, and that's modulo 5. So every one of these, you draw a different picture for it. Now, does 5 equal 2? Okay, if I go around this thing, if I make 5 moves, 1, 2, 3, 4, 5, where did I end up?
2.
So 5 equals 2 in modulo 3. You just draw the circle and just run around the circle. What's the one with modulo 5? Oh, 43, 6 equals 7. Does 6 equal 7? I don't know. Let's see. 1, 2, 3, 4, 5, 6 ends up at 1. 7 ends up at 2. So no, they're not equal, are they? 6 doesn't equal 7. Now, in problem 48, modulo 10, what's 2 plus 9? What's 2 plus 9 in your head?
11.
And if I only have 10 places,
Then it's 1.
then it's 1 beyond 0. See how you kind of want to jump back and forth, whether I'm using a chart? Well, on your chart handout, don't you have a table for modulo 5?
Yeah.
So you could use a table for modulo 5, or you can use a picture, or you can just do the math and think about how you're going around in circles again and again. Okay. Number 56. Okay, 54. What's 3 times 3 in modulo 5? Now, your chart tells you 3 times 3 is 4. But what's 3 times 3 in your head? 9. But you only have 5 times to go around. So after you subtract 5, what's left? 4. In problems 59 to 74, find the value for n that makes the sentence true. Oh, well, all that is 59 to 61, that's just a distributive property. 4 times 3 plus 0, isn't that the same as 4 times 3 plus 4 times 0? Do you remember the distributive property? Is that on here? No, it's not. Number 72. Oh, 68. 2 equals n minus 1. Add 1, add 1. So what does n equal? 3. Everybody see what's going on? Just rewrite the subtraction as addition. And 72, n over 3 is 2. So that would be n equals 2 times 3. What's 2 times 3? In modulo 5. What's 2 times 3 in your head?
Well, 6.
6. But modulo 5 only goes 1, 2, 3, 4. 1, 2, 3, 4, 5. And one more would be 6. So what's the answer? 1. Do you feel powerful? Well, stop when you get to 73. And let me turn this off and help you talk about your test.